Welcome, folks. Today we are discussing a fascinating study on the combined effects of climate stressors and soil arsenic contamination on rice production. It's a complex issue with significant implications for food security and public health.
I see. So, this study looks at how climate change and arsenic in the soil interact to affect rice, right? What are the key climate stressors they focused on?
Exactly. They focused on three major environmental variables: elevated atmospheric carbon dioxide, ECO2, elevated ozone, EO3, and elevated temperature, ETemp. These were tested individually and in combination, along with varying levels of arsenic contamination in the soil.
And what about the arsenic? How did they incorporate that into the experiment?
They used two environmentally relevant concentrations of arsenic in the irrigation water: a low dose, LAs, and a high dose, HAs. This allowed them to see how different levels of arsenic interacted with the climate stressors.
Interesting. So, they essentially created different scenarios simulating future climate conditions and arsenic levels. What were the main findings regarding rice growth and yield?
Well, the results were quite complex. ECO2 generally had a positive effect on shoot biomass and yield, but this was often offset by the negative effects of EO3 and especially ETemp. ETemp, particularly in combination with high arsenic levels, led to the most severe yield reductions, up to 66% in some cases.
Wow, that's a significant decrease. Did the arsenic itself have a major impact independent of the climate stressors?
Absolutely. High arsenic levels consistently reduced yield regardless of the climate conditions. Even with beneficial ECO2, high arsenic severely hampered growth and grain filling. The low arsenic levels showed some positive effects on growth in certain conditions, but the high arsenic levels were overwhelmingly negative.
So it seems like the combination of climate change and arsenic contamination creates a double whammy for rice production. What about the nutritional quality of the rice? Did that change as well?
Yes, the study found significant alterations in the nutritional content of the rice grains. Elevated temperatures, particularly with high arsenic, reduced protein and free amino acid levels dramatically. ECO2 and EO3 generally increased starch and amylose levels, but again, the high arsenic levels often negated these positive effects.
That's concerning. Less protein and amino acids means lower nutritional value for people who rely on rice as a staple food. What about the arsenic levels in the rice grains themselves? Did the climate stressors affect how much arsenic ended up in the rice?
That's a crucial point. ECO2 slightly increased arsenic accumulation in the grains, especially when combined with high arsenic levels in the soil. This is worrying because it could increase the cancer risk for people consuming the rice. However, EO3 and ETemp tended to reduce arsenic accumulation.
So, there's a bit of a trade-off there. Reduced arsenic, but also reduced yield. How did they assess the potential cancer risk?
They calculated the incremental lifetime cancer risk, ILCR, based on the arsenic levels in the rice. The ECO2 plus high arsenic scenario showed a significantly higher ILCR, indicating a greater cancer risk. But EO3 and ETemp scenarios showed lower ILCRs.
That's a really important finding. It highlights the complex interplay between climate change, arsenic contamination, and human health. Were there any other significant findings related to the metabolic profiles of the rice?
Yes, the study used GCMS analysis to examine the metabolic profiles of the rice grains. They found that ETemp significantly reduced the number and levels of various sugar metabolites, which could affect the taste and quality of the rice. Arsenic also altered the metabolic profiles, further impacting the nutritional value and potentially the taste.
So the study paints a rather grim picture, doesn't it? The combined effects of climate change and arsenic contamination seem to pose a serious threat to rice production and food security, especially in arsenic-affected regions. What are the implications of this research?
You're right. The implications are significant. We need to develop rice varieties that are more resilient to both arsenic and climate stressors. This requires further research, including field trials under various conditions. We also need to consider the implications for public health and develop strategies to mitigate the risks associated with arsenic contamination in rice.
Absolutely. This research highlights the urgent need for integrated approaches to address these interconnected challenges. Thank you for this insightful discussion.
My pleasure. And thank you to our listeners for joining us today. Until next time, Goodbye.